Today we will talk about the centralized granular access control of QuickSight. In our first session, are you able to see my screen, everyone?
Yeah,
Yes,
I
yeah,
can see it.
uh-huh.
Yeah. In our first session, we discussed about admin console. That's a dashboard, a centralized visualization method to view all the usage metrics and the relationship, the catalog of QuickSight assets. And in the second series of sessions, we were talking about BI operations to do the CI/CD pipeline by using QuickSight public API. And in this one, the final series of session is about the security architecture setup. And this one is always pain points for the BI admin and BI architecture. Um, how can we automate the security architecture setup? And what's the best practice? And how can we apply the granular access control based on the different user group? That's always an interesting topic and is a very difficult task to be finished. And last year, I published a blog. And in that blog, I provide the methodology, the best practice, and also a package CDK framework for you to deploy in your environment, and suggestion about the row-level security design. And this year, Niharika did a great job. She helped our team to convert it to be a workshop and publish publicly by using the workshop studio. And Niharika will support you to walk through it step by step. Um, on high level, the design is how can we use different namespace to isolate the user and group? And then how can we use different group to do the object access definition? And also how can we do the data segmentation by using the row level security and column level security with the associate QuickSight group. And here is the diagram here. And here it is workflow from authentication to authorization. And here is the link of the blog and the introduction of the API and the high-level introduction of AWS CDK. So, yeah, I will skip the part to introduce myself and directly go to the contents of today's topic. Here is the diagram of the granular access control. So let's say we have internal team and external team. Usually we put the internal team into the default namespace. And in default namespace, you can have the reader, the author, the admin. And the author and the admin, they can develop the dashboard and then publish it and embed it into application server or whatever. And then using the identity store to save the user information and group information, and then do the authentication to allow the user in all the other different namespace to be able to view the dashboard. And in the custom namespace, you might have like a third-party team. The third-party team is someone which is your customer, and you would like to isolate them. They can create their own dashboard. They can view the dashboard you release to them. But when the author in the custom namespace, third-party namespace, when they develop some dashboard, they are only from UI, they are only able to share those dashboard to the reader inside the namespace. From UI, this also never be able to view the users belong to the other namespace. If they really have the requirement to do the dashboard sharing, they can contact you. And you as admin, you can call the API to share the dashboard they create to the other namespace. Otherwise, they don't have any permission to do that. So here, be careful. The namespace only isolate the user and group, never isolate the dashboard the datasets. But because from UI, we isolated the user, we don't allow you to see the user belong to other namespace. So it's kind of acting like isolated the assets. But in theory, we don't isolate the assets by using namespace. We are still able by calling API to make the assets to be shareable across different namespace. And once we have the structure for the user and group isolation, then we can think about that, how can we do the object access permission assignment. You have a dashboard and you would like to allow someone to be able to view it, or maybe to edit it, or maybe furthermore, to own it. Own means you can delete it. The best practice is always don't do that with individual user. Always do it with QuickSight group. You create the QuickSight group, and then according to the group, you allow someone to be reader, to read one of the dashboard, and you allow someone to be author of the same dashboard, and you allow someone to be the owner of the same dashboard. And for this kind of group, I give it a name to be object access permission group. Those group only control the object access permission. Besides that, we would like to do the data level segmentation. How could we do that? And by doing that, we create another sets of the group. And for those group, we let them to be able to associate with the row level security rule and also the column level security rule. So we are using those group to separate the different data level access. A user can be in the one of the object access permission group, and also he or she might be in the data segmentation group. So we can use these metrics to control the object access and also the data segmentation. And the data set, as we already know, you have the actual data source and you have the row level security data source, and you apply the row level security on top of the actual data. These two data sources can be merged together, no problem. You can also separate it. One is Redshift, another one may be Athena. And you can apply the row level security on the actual data, and then according to your row level security, the data segment group setting, you can allow different users to view different parts of the data. This one is the high level architecture diagram. If you feel, oh, I'm confused, don't worry about that. We will dive deeper one by one in the later slides. So here, this one is what I'm talking about. In our CDK package, I prepare some sample by using the JSON string. And the JSON string in the CDK package, I save it into the system manager parameter store. And why I use JSON string? Because JSON string can handle the unbalanced structure. So in here, I put two JSON string into two different parameters. One parameter is for the group and the user role of the group. Let's say in default namespace, you have a BI developer team, and often they are author. In default namespace, you have a BI admin team, often they are admin. And in default namespace, you have a power reader team, and they are author. What's mean about power reader? They are able to view the dashboard, and they are able to create a dashboard, but you don't want them to be able to share the dashboard to the others. So you are able to make it to be power reader, but it's not the same as the fully author permission as the BI developer. You can use the scope down IAM policy to control it by restrict the update dashboard permission action. And you can have some reader group according to your security level. For example, you might have some dashboard belong to critical security restriction. So you create a critical group and their reader. And later I will tell you how can you restrict the critical and highly confidential. And you have another group, highly confidential, okay, their reader, and so on and so on. And in here, I use another JSON string to control the object access. That's what I define here called object access permission group. So as I say for critical group, they are reader, right? And there are some reports or dashboard belong to the critical security restriction. So you allow everyone in this group to be able to view the dashboard in this array, all the critical data. And there's another group, highly confidential. And there's some dashboard, the lower security level, they only highly confidential, no critical, and you allow them to be able to view the dashboard belong to the highly confidential security criteria. And for the BI developer group, they are able to view and edit all of the report. When you detect all, then you will know, okay, that's belong to BI developer and BI admin. I will release all the dashboard and report to those group and give them the full permission. And here is some sample here, different group name belong to different namespace and their permission, and the notes give you the detailed information. And here is the one diagram to show you, let me put it here, to show you the relationship between different group. One user, if he is falling in this overlapping area, that's 3 different group, critical, gray British, and also the PII. That means the user in here belong to these 3 group. He or she able to view the critical data, and in the column level security, he or she able to see the PII columns, and he or she able to, according to row level security, to see the data only belong to UK, the gray British. And if in here, that means this user cannot see any dashboard related to critical data, cannot see any column belong to PII. And in row level security, he or she only be able to see the data related to USA. Yeah, and also according to some other setting, if you have some other group limitation here. But that's the Venn diagram to show you how can we define the group metrics to restrict the user access, both on object access level and the data access level. And here is the information to show you the details. You can use non-PII and PII to control the column level security. And you can use all country to allow the user belong to this group to be able to view all the different country. And you can use the country name to define the group name and allow the user to be able to only see the data belong to this specific country. Yeah. And the end-to-end workflow is you can create a group, let's say QuickSight federated users. And this group is a public group, including every user. And then you give them a role. The IAM role is QuickSight federated users, and only provide one action, say create a reader. So when the user first time log in, if they pass the authentication to, you can use single sign-on, AWS single sign-on, or any other tool, Okta or whatever. And when they first time log in, you will create a reader account for them. And according to the minimal access permission, they have their reader account, but nothing they can see, nothing they can see. And then in the authorization workflow, I created several Lambda function in the CDK package. You can also convert them to be the glue job. You can also convert them to be Java package and then deploy it by EC2 or ECS, whatever you would like to do. Either way is fine. In this POC, we pack them into the Lambda function. And the Lambda function can do different steps. First thing first, you have all the users. And according to the parameter I show you in the different SSM parameter, we read the JSON string saved in the parameter, and then we raise some of the reader to be author, or raise some of the reader to be admin. And according to the sample parameter, define the object access and the data segments. We assign the user into different group. And when we assign the user to different group, they're able to inherit the group level setting to be able to view the dashboard. His or her group allowed to view. And also according to the group, like the GBR, the UK, the USA, they're able to view the data according to their role level security setting. And when they really open a dashboard, because we already pre-set up something in the row-level security datasets, so they are only able to view the data according to the row-level security we specify in the security rule. And those Lambda function, you can let them like run hourly. You can let them run weekly. You can also trigger some events to do the real-time policy assignment. I say it to be hourly because we don't want to abuse the QuickSight API usage. The API usage, you might suffer the throttling. And if you continue to keep the Lambda function wrong and wrong and wrong, it definitely have some latency. And the latency will be dynamic if you are using event trigger. So if you generate a lot of user confusion. But if you are using the hourly permission assignment, then the user, they know, okay, you have to wait for 1 hour to get your permission. Don't expect it earlier. It's better to set up the user expectation. Yeah, and everything I mentioned about the namespace, the group, the username, everything we save in the membership.csv. I provide a sample in the CDK package. And all the row-level security, those definition, actually we are using the real data to join with this one to generate the SQL query for the row-level security assignment. The details is in later slides. So here is the authorization workflow. Yep, and here is the Lambda function. So every time when the user trigger the user initiation Lambda function, and in the user initiate Lambda function, you can do something like, hey, I provide landing page dashboard. And in the landing page dashboard, everyone can view it, no sensitive information. Just give you like how many dashboard do we have and the corresponding permission group. So the end user, they can check it and apply for the group they would like to join in. And in here, I set up event bridge hourly rule. So every hour we trigger Lambda function. The Lambda function will do it one by one to do the user group assignment and let the user to be in the correct role. And if someone we would like to downgrade from admin to author, then we trigger the downgrade user Lambda function to do the downgrading. If no one to be downgraded, no problem. We finish the loop and say, hey, no one to be downgraded. And this one, we assign the different group about the user, the object access permission, and the row level security, the data segments group. And finally, we will run this Lambda function to get the updated group user mapping information and save this information into the group membership CSV and the object CSV to save the data for you to be able to view them in your admin console dashboard. If we have any error message, we will also save into the S3 bucket. So you can always do the auditoring by checking the error logs. And here is the sample of the membership.csv. You define the namespace, default or third party, and you define the data segments group, and you also define which user and what's their user email. And then in here, that's something you might already have in your HR database, data warehouse. You recall your users' information, like which country they are belonging, which city they are belonging, and their job title, their employee login, and their employee name. And you can generate a view or data sets by combine all the information together to get the QuickSight group name, QuickSight username. Be careful for the federated user. The QuickSight username always concatenated the session name and the email together to be the username. And then you can get information like this user belong to which country and locating in which city. And once you have the information, then you can construct some SQL to build a row-level security datasets. And then when we set here, that means if anyone in the all country group set the username to be null, that means every user in the all country group be able to see all the country or the city. Any user belong to the UK group be able to see all the information belong to Great Britain, and city now means every city, and similar for USA. And if this user doesn't belong to any those group, that means we use the user level, row level security to control it. So this user, Nathan, he will be only able to see USA Asia, nothing else. And Jeremy will be only able to see the data belong to USA Atlanta. And be careful, if Jeremy he belong to one of the group, say all country, that means Jeremy can view all country data, or the city belong to him, because he already belong to all country, so the user level permission is useless. But however, if Jeremy belong to the GBR group, that means he is able to view all the data belong to Great Britain, and also one more city belong to USA. So by doing that, you can build the row level security metrics to assign the granular security control by using our powerful ILS rule the permission. And yeah, that's the information of the granular access control, including the high-level diagram architecture and the workflow and a concrete sample of the low-level security. Niharika will walk you through how to do the hands-on deployment. And thank you very much. Niharika, it's your stage. You can share your screen. Thank you.
Yeah, so the first step is to deploy the CDK stack. So we will download the CDK stack from the Git repo, and I'll send you the link to the Git repo in the chat window. So once you're on the Git repo, so you can clone this Git repo by clicking on this code here in green box. And then you can either download the zip or copy the link from here. And then from the terminal, You can just clone with this command. Hit clone and you can paste the link that we copied from the Git repo. I'll wait for a few seconds for you to download. So after we have downloaded the Git repo, so now we can go ahead and set up our environment to deploy the CDK stack. So for that, so the first step is to log into our AWS account, and then we set up our environment through the Cloud9. So once we are in our AWS account, so open the Cloud9 by typing it in the search bar. And once we are in the Cloud9 environment, so we can go ahead and click on create environment. So this will create a EC2 instance, and you can give any name that you like here. So I'm gonna enter as Granular Access Workshop, and then click on the next step. And for configure setting, we can leave everything as default for all the sections. And then we can click on next step. And then we can review all the information, and then we can click on create environment. Now this will create our EC2 instance. So this might take like anywhere between 2 to 3 minutes. In case if you all have any questions, please post your questions in the chat window. Me or Ying will assist you with your questions. All right, so my environment is set up. I'll wait for few more seconds for you all to catch up as well. All right, so now that we are in this environment, so the first step is we have to upload the Git repo that we have downloaded to this environment so that we can use that to deploy the CDK stack. So to upload the downloaded folder, so we have to go to File from here and then upload local files. So we have to select upload local files. And then because we have to upload the folder, right? So we can select folder. And then we can go to the folder that we have just downloaded, the Git repo. And we can upload just the granular access. So you will notice that this is the folder that you have downloaded, like the Amazon QuickSight SDK ProServe. And because we want to use only granular access stack in this workshop, so we can go ahead and select the granular access from here and then select upload. And then you can, so we will get a pop-up and we can just select upload from here. And this might take like 2 or 3 minutes uh, for all the files within this folder to be uploaded into this environment. We have around 30 more files to be uploaded, and that's done. So my files are now uploaded. So I'll wait for some more time for you all to catch up as well. So after the files are uploaded, we are going to do the instructions that are laid out in prerequisites and initial setup section. And the commands that we are going to use are under setup your environment and deployment. All right, so now that the folder is uploaded, so what we can do is we can right click on the granular access here, and then we can go to open terminal here. So this will open a window here. And after that, we can start from source.when, like to create the virtual environment. So I'll execute this command. And then we will do the pip install requirements.txt command. All right, so after that is completed, so we will execute the series of commands one by one. So the next one I'll do is pip install AWS CDK.aws S3. And then I'm gonna install AWS S3 deployment. So that's completed. So now I will install the AWS events targets. All right. So after that is completed, I will install pip install Boto3. Yeah, so that is completed as well. So I'll wait for like few minutes for you all to finish those commands as well. All right, so now that we have installed all the necessary packages, we can now execute the bootstrap command. So for that, I'm gonna use CDK bootstrap command and then run it. So this is finished. So after bootstrapping the environment, so we can now go ahead and deploy our CDK. So for that, we can just execute CDK deploy granular access. So you will get a prompt asking if we want to deploy these changes. We can, oh, uh, sorry about that. Let me log in again. Yeah, so here for the prompt, we can just go ahead and enter Y. This might take like a minute to create all the resources in our AWS account. So we have 24 resources created and 3 more to go. Yeah, so now the granular access stack is deployed in my AWS account now. Um, I'll wait for like just a few more seconds to allow time for you all to finish as well. So after deploying the granular access stack, it should create 5 Lambda functions and a few resources in the system parameters. So once they are created, the next step is to set up the Lambda functions. to enable the authorization of the QuickSight assets. So for that, we have to go to the Lambda service first. So from the AWS account, we can navigate to the Lambda. And here you can see that the resources are created for me. So these are the 5 Lambda functions that are created. So as a step one, like we have to set up destinations for these Lambda functions. So first we have to go to the granular user governance. So for that, we can simply click on it. And then to set the destination, we have to go to the configuration tab. And then on the left pane, go to destinations and then select add destination. And on this page for source, we can leave it as asynchronous invocation. And for condition, we have to set it as on success and then set the destination type to Lambda function. And the destination Lambda function will be downgrade user. So we can start typing in as downgrade user and it will show the Lambda function in the dropdown and we can go ahead and select that. And once these settings are completed, we can click on save. So after we have completed the settings for granular user governance, so the next one is the downgrade user Lambda function. So we can go back to the functions tab and then select downgrade user. And we can follow the previous steps. Go to the configuration. And then from destinations, we can click on add destination. And for the settings, we can leave the source as asynchronous invocation and set the condition as on success and destination type as Lambda function. And the destination Lambda function is granular access assets governance. So as soon as I click on the search bar under the destination, I can see the Lambda functions list here and I'll select the granular access assets governance and then we can click on save. So now that this is done, we can go back to the functions and then select downgrade user again. We will add one more destination for this Lambda function. So the previous one was for on success condition and the new one is for on failure condition. So on the right side, I will click on the add destination. And the source is same, asynchronous invocation, but I will I will leave the condition as on failure and destination type as Lambda function. And now the destination will be check team members. And then I'll go ahead and click on save. And as a last step, I will select granular access assets governance. And I will create a destination for this function as well. And I'll leave the sources as asynchronous invocation again. And we can set the condition as on failure or on success. So I'll leave it as on failure here. And then I will set the destination type as Lambda function. And the destination will be check team members. And then we can save the settings here. So once we set up these Lambda functions, so now we can go ahead and create our QuickSight resources. to test the Lambda functions. So before we create the QuickSight resources, we have to first set up the data sets in the Athena and S3. So I will post 3 files in the chat window that we are going to use to upload them to S3 and create Athena tables and QuickSight assets using these files. All right. So first we will upload. So I have posted 3 files. 2 of them are CSV files, employee information and fact revenue. So now in this step, we are going to upload these 2 data files into S3 bucket. So for that, we can navigate to the S3 and then we have to create a bucket here by clicking on create bucket on the right. And then you can enter the bucket name as QS dash granular access employee. And we have to provide our account ID, AWS account ID. Since I already have a bucket name created with this name, I'll just add one for my new bucket name. And for account ID, you can navigate to your name on the top right, and then you can copy the account ID from here. And then I'll just replace the account ID with my actual account ID. And once you give the bucket name, like you can leave rest of the information as default, and then we can go ahead and create bucket. So after the bucket is created, we can see the new bucket name under the list of buckets. So now in this one, we will create 2 separate folders for our 2 data files. So one is employee information. We can go to create folder and provide the name as employee information. And then create folder. And after that, we can create one more folder as fact revenue. I'll pause here for you all to catch up. After these folders are created, we will upload the 2 CSV files into the respective folders. So once the folders are created, so I'll go to the employee information and then I'll upload a new file here. And similarly, for fact revenue, I'll upload the fact revenue folder. So now that we have uploaded our files here, we can go ahead and create the Athena tables. So for that, we have to first go to the Athena. And then as a first step, we will create a Athena database. So for that, you can execute create database granular access command. And after you type in create database granular access, you can hit on run, and that will create a database similar to this one. So once the database is created, the granular access database, we can now create our tables using the S3 files. So the first table that we are going to create is employee information. So for that, you can copy the SQL from the workshop. This SQL is available under create row level security datasets section. So I'll just copy that and paste it here. And then for account ID, I'll just provide my account ID. And then I'll execute run. So this created the new Athena table. Similarly, I will create the other tables as well. So the second one is the RLS table. So here we do not have to provide any account ID because it's a view. So I'll go ahead and run. Awesome. So this is completed as well. And then the next one is the table that we will create using the fact revenue file. So I'll copy the SQL from the workshop and then I'll paste it here. So here, because we are creating this table using the S3 file, we have to provide our account ID here. And then I will run this query. So that will create a new table. And the last table that we are gonna create is RLS dataset view. So I copied the SQL from the workshop and I'll hit run. So that created a view for us. So we will use fact revenue to create QuickSight dashboards, and we will use RLS dataset to implement row level security on these dashboards. So now that the Athena tables are created, we can create QuickSight assets now. So for that, let's navigate to the QuickSight. So before we create any assets in QuickSight, we have to make sure that QuickSight has access to the S3 bucket and Athena we have created. So for that, I'll go to the my login name on the top right, and then I'm selecting Manage QuickSight, and from here I'll go to Security and Permissions on the left pane. So in this section, under access granted to services, I will select manage. And for Amazon S3, I'll make sure that my new S3 bucket is selected. And then we can select finish. And the Amazon Athena is also enabled here. So I'll go ahead and click save. So I'll go ahead and do one thing. I'll create the resources manually. So first is we have to create a Athena data source. So I'll name the data source as Granular Access. And then I'll select the Granular Access Athena table. For creating the data set. And then I'll select the fact revenue. So this will create a fact revenue data set and also a granular access data source. So I'll go ahead and click on save and publish. So while that is being created, I'll create one more data set using the data source we have created for our RLS data set. So I'll go ahead and select the Athena table. And then we want to use the RLS data set. So this RLS data set is used to give permissions to the dashboard. And then I'll do edit and preview. And then I'll go ahead and select save and publish. So now we have two data sets created. One is the fact revenue and the other one is the RLS data set. So using fact revenue, we can set up 4 QuickSight dashboards. So I'll create an analysis quickly. And then we can like provide any random visual to test our permissions. So I'll name this as sales critical analysis. And then I'll publish this as a dashboard. And then I will provide the dashboard name as sales results critical. And then I will create one more dashboard using the same fact revenue. And I will name it as sales results highly confidential. And then I will publish this as a dashboard with the same name. Awesome. So now that our data dashboards are created, so we can test the row level security by applying the RLS dataset on the fact revenue. So for that, we can simply we can simply select the fact revenue dataset and then apply row level security. Under user-based rules, we can select the RLS dataset and choose apply dataset. And under the prompt, we can select apply and activate. So now we can see that the permissions dataset is now applied on the datasets. So now what will happen is the Lambda functions that we have created previously, so they execute like every hour. So once they are executed, the permissions are applied on these dashboards in such a way that so only the users that have access to these dashboards and also the data within the dashboard will be able to view. So now for these dashboards, you can see this log icon applied here. So that indicates that there is a security applied at the dashboard level. Now, when I try to view the dashboard, we can see that we get a message saying that I cannot access this visual because I do not have permissions to it. So The RLS table that we have created, right? So that will not contain my username. Like if we view the data, so this here, this list does not have my username. So that is the reason I'm not able to view the data. So which is like a good thing. So in to this list RLS dataset, like we can add the groups or usernames to whom like we want to enable the data level access to these dashboards accordingly. And when we apply this RLS dataset to our fact tables, the permissions will be applied accordingly. So that's it. This is how we deploy the granular access CDK stack and then also apply the row level permissions. Let me know if you have any questions.